Hello, our objective today is that you will find missing sides of a right triangle using trigonometry. The next objective is that you're going to find missing angles of a right triangle. So you're going to notice that these problems look the same to begin with. So first example, we've got a right triangle here. We've got 29 degrees as a reference angle. One side that we are looking for is x that we don't know, and this side here is 15. So let's start by labeling what we know. So our reference angle theta is 29 degrees. So I'll just write that down. The opposite side is the angle that's across from 29 degrees. So in this case, that is the x. The adjacent side is the leg that is next to 29 degrees. Now don't be fooled, that 15 is not a leg because it's the longest side. It's across from the right angle. The adjacent side is this leg right here. So that leg, you notice, they didn't give it to us, and they're not asking for it. So I'm just going to scratch this out. This does not, it's not going to be part of our problem. And then the hypotenuse is that 15. Now, in order to solve equations using the information we know, we are going to have to choose sine, cosine, or tangent. So this is where SOHCAHTOA comes into play. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In this case, we have opposite, and we have hypotenuse. That means we're going to choose to use sine. It could have been any of them. That's just what we happen to have. So we're going to use sine, and then we're going to set up an equation using SOHCAHTOA, with sine. So our equation is going to be sine of our reference angle, so sine of 29, is equal to opposite over hypotenuse. So that's x over 15. Now sine over 29, you can type into the calculator and it will give you a number. And we are going to do that in a moment, but just be aware what we have now is an equation where a number is equal to x divided by 15. And the way you would solve this for x is to multiply both sides by 15. Now I'm going to show this step right here, but probably in the long run you're not going to show times 15 times 15. So what that gives us is 15 sine of 29. And we usually write that multiplied number in front and not in back, is equal to x. The 15 and the divide by 15 cancel each other out. So we're actually done with the solving part because x is by itself. The only thing we need to do is to type this into a calculator, and that will give us exactly what x is. So I'm grabbing my calculator right now. I'm making sure it's on degrees. I'm typing 15 sine of 29. And in this whole packet, we're going to ask you to round to 2 decimal places. So this comes out to 7.27. And there's a couple ways that I could check this, but just as a quick eyeball, if you look at this, 7.27 does make sense because that's a leg and it should be shorter than the hypotenuse. Sometimes if you make a mistake, this will end up coming out longer than the hypotenuse, and you can catch it like that. Let's look at the second example. In this example, our reference angle is that 41 degrees. So that's theta. Our opposite side is the one that's across from our reference angle, and that's the side that's blank. So we're not even going to be using the opposite this time. And every time you do this, you're going to scratch out one of these. Your adjacent side in this case is 15. That's the leg that's next to our reference angle. And then the hypotenuse in this case is what we don't know. That is x. So let's take a look at what we have. We have adjacent and we have hypotenuse. So going back to SOHCAHTOA, that's cosine. That's the only one we can use here. So we're going to use cosine. Again, could have been any of the three. And now we can set up our equation. So our equation is cosine of our reference angle, and you have to write that, cosine of 41, is equal to adjacent over hypotenuse. So this one is 15 over x. Now, you might notice why we're doing this second example. In the last example, the variable we were looking for, x, was in the numerator. In this example, it's in the denominator. And we're still going to start the same way, but it's going to end up being one more step. So in the last example, we multiplied by the denominator, times 15 times 15. We're going to do that here too, times x. It's just, unfortunately, this isn't going to get x by itself for us. So when we do this, we get x times cosine of 41, and you do need to write all these steps, sorry, that was 41, is equal to 15, because the x and the divide by x cancel out. And then the last step to get x by itself is that we divide by cosine of 41, the whole thing at once, and that will cancel out on the left side and give us x by itself. So divided by cosine of 41, divided by cosine of 41. So these cancel, and we get x is equal to 15 divided by cosine of 41. And you notice this was one extra step compared to the last one, but now at this time we are ready to type it into a calculator because we have x by itself. 15 divided by cosine of 41 is equal to 19.88. If you were rounding to 2 decimal places. Let's eyeball our answer again. X is the hypotenuse, so it should be the longest side, and we did get a number that was longer than the leg of 15 that they gave us. So we have found some missing sides of a right triangle using trigonometry.